In our last unit, we spent quite a bit of time examining how to get a sample from a population. So why do we actually even do this? So we take a sample and we collect data from a representative sample, meaning a sample that closely mirrors the population. And from there, we can perform data analysis on the sample, and we can use the data that we get from our analysis to make an inference about the population. So this is the full cycle that we're going to go through. We've learned about how to collect the sample or how to select the sample. Now we're going to learn about how to collect and analyze the data. So at the broadest level, statistics is the science of data. So it's fitting that we would start the year with our second unit on data analysis, which is the process of organizing, displaying, summarizing, and asking questions about data. In this video, we're going to be focusing predominantly on the organizing and displaying of data. Any set of data contains information about some group of individuals, and the characteristics we measure for each individual are called the variables. So let's say AFBHS has a database about every currently enrolled student. The students are the individuals described by the data set. And for each individual, the data contains values of variables such as age, gender, grade point average, advisor, grade level, address, etc. Right? We can break these variables up into two groups. Categorical variables, which place an individual into one of several categories. So an example of a categorical variable would be something like your gender, your grade level, what advisory you are in. Whereas a quantitative variable takes numerical values in which it makes sense to find an average. So that would be something like age or GPA. We can talk about the average age of an 11th grader. We can talk about the average GPA of a 12th grader. But a caution that not every variable that takes a number value is quantitative. So for instance, let's look at zip codes. Right? Zip codes are a way of placing individuals into a category based on location. It doesn't make sense to take an average zip code. So a zip code would be an example of a categorical variable that's numerical. So a variable generally takes on many different values, and we are interested in examining how often a variable takes on each value. This is called a distribution, and this is going to be a word that you're going to hear throughout this year. You're going to hear about the distribution of data. And what that means is a distribution tells us what values a variable takes and how often it takes those. So for instance, here we have some car models and their average mile per gallon that they get when they're driving. So the variable of interest is the miles per gallon that the cars get. We can use this dot plot to examine how frequently a car gets a certain number of miles per gallon. So we can see that 3 cars get 25 miles per gallon, 3 cars get 29 miles per gallon, 1 car gets 32 miles per gallon. This is the distribution of the data. We're going to be focusing today predominantly on categorical variables. We'll touch on quantitative variables later this week, but categorical variables, recall, place individuals into one of several groups or categories. And we can use a table to display information about categorical variables. So here we have two kinds of tables of types of radio stations. So we have our variable is types of radio stations, and each different type is a value of that variable. So country radio is a value of the variable type of radio station, right? And then this column on the right gives us the count of stations, or the number of stations that are country music. So out of a total of 13,838 radio stations, we can say 2,066 are country. When you give a count of how often something occurs, that is called the frequency with which something occurs. So we keep track of that in a frequency table. Frequency is how often something occurs. That is in contrast to this table on the right, which is a relative frequency table. And what a relative frequency table does is it displays the same data, but now in terms of percentages. So let's say we wanted to calculate the relative frequency of adult contemporary radio stations. We would take 1,556 divided by the total number of stations, 13,838, and that would give us 11.2%. So the relative frequency of adult contemporary stations is 11.2%. You need to know this difference between a frequency table and a relative frequency table. So I want to draw your attention to one thing. It's a good idea to check to make sure that your data are consistent. So the counts in this column should add up to 13,838 because that's the total number of stations, which they do. The percents in your relative frequency table should add up to 100%. Here they add up to 99.9%. So what happened? Each percent is rounded to the nearest tenth. So if we were taking the exact percents, they would add up to 100, but the rounded percents only come very close. This is called round-off error. Round-off errors don't point to mistakes in our work. It's just the effect of consistently rounding our answer. So frequency tables are great, but they can sometimes be difficult to read and difficult to really get information from. So sometimes it's easier to analyze a distribution by displaying it with a bar graph or a pie chart, both of which you've seen before. So let's start by talking about bar graphs. Bar graphs represent each category as a bar. Notice the categories are listed on the x-axis. The bar heights show the category counts, or we could also use the percents. Bar graphs are easier to make than pie charts, and I also think they're easier to read. So they're also more flexible than pie charts, which we're going to talk about more in a second. So although both graphs can display a distribution of any categorical variable, a bar graph can compare any set of quantities that are measured in the same units. A pie chart we use often to display relative frequencies. Pie charts show the distribution of categorical data as a pie whose slices are sized by the counts or percents for the categories. So a pie chart must include all the categories that make up the whole. In the radio station example that we just talked about, we needed to know this other formats category so that we could be clear on the total number of radio stations and use that to make a pie chart. We use a pie chart only when we want to emphasize each category's relation to the whole. Pie charts are a little bit awkward to make by hand, but fortunately technology can do it for us. Let's now watch a video from the textbook publishers on how to display data.
Hi, this is Jason Molesky. In this example, we'll take a look at how to construct a bar graph for a set of data. We'll also see whether or not a pie chart would be appropriate for that same set of data. Portable MP3 music players such as the Apple iPod are popular, but not equally popular with people of all ages. The table here displays the percent of people in various age groups who own a portable MP3 player. This data was gathered from a randomly selected group of 1,112 individuals in an Arbitron survey. The first part of the example asks us to make a well-labeled bar graph to display the data, and then describe what we'll see. To do this, we'll first need to start by labeling our axes. The horizontal axis will be labeled with our age group in years, 12 through 17, 18 through 24, 25 through 34, 35 through 54, and 55 and older, while the vertical axis will represent the percent who own an MP3 player. We'll run this axis from 0 through 60 since the highest percentage is 54. Make equally spaced marks and label each by units of 10. To make the bar graph then, what we'll need to do is draw one bar per category whose height corresponds to the percent owning an MP3 player in that particular category. As you can see then, we end up with 5 different bars. Notice they don't touch since we have different categories here, and the heights of each correspond to the percents in the table. We can see in this bar graph that it appears MP3 players are more popular among young people, and that their popularity generally decreases as the age category increases. The next step of the example asks whether or not it's appropriate to make a pie chart for these data, and explain why or why not. To answer this question, we'll want to look at the percents owning an MP3 player. Notice they range from 54% for the age group 12 through 17, down to only 5% for the age group of 55 and older. Also notice when we add these percents up, we get a number far greater than 100%. That alone tells us that making a pie chart would not be appropriate, because each percent in the table actually refers to a different age group and not to parts of a single whole.
So Mr. Tabor spoke in the video about what makes a good bar graph, but I want to make sure that you very, very clearly have the criteria for success laid out. So the criteria for success for a bar graph are listed right here. We need to have the same width bars and the same space between the bars, because these are separate categories. Our axes need to be scaled, meaning they need to have these numbers here, and they need to be labeled. A title is optional, it's not required, but something that really is required every single time is your vertical axis must always start at 0. There's one other way that you sometimes see categorical data displayed, and that is a way that we will never ever use. That is called a pictograph, which is what I have shown here. And a pictograph is a way to represent data with some kind of visual that's typically appealing. The problem with pictographs is that they can often be deceiving. So let's look at this pictograph here. So my 1960 trash can says that the US produced 80 million tons of trash, right? And in 1980, the US produced twice as much, 160 million tons of trash. But the problem with this pictograph is that actually we doubled both the height of the trash can as well as the width of the trash can. So the area is roughly 4 times the size of in this 160 million ton trash can versus this 80 million ton trash can. And the reason that's a problem is because our eyes respond to the area of the diagram shown, which is why it's important to draw bars of the same width in our bar chart, right? We don't want one to look bigger than the other because it's wider, but that's exactly what we've done here. So the pictograph is something that we are never going to use in this class, but when you see in the news or on the news or in the newspaper, you need to be a very critical observer of the information contained in the pictograph. This means, since we're not using the pictograph, you should be prepared to represent categorical data in one of the 2 ways that we discussed in this video, using a bar chart or using a pie chart. We will get into making these later this week.